My name is Liliana Ramos, y I'm a chemistry teacher at Ronald Reagan Doral Senior High. I have been part of the Research for Teachers program for the past 3 summers, and before I start with my presentation, I would like to thank Aesthetic Consortium for giving us, high school teachers, this wonderful opportunity. Also, I would like to extend the thanks to my mentors, Dr. Vived, Dr. Jahavi, and Dr. Vanshali for their help and support throughout these 7 weeks. The goal of our research was just to find the optimal parameters of copper nanoparticles ink to be used in the 3D printing of small electronics. Why copper nanoparticles ink? Because copper nanoparticles ink are more affordable than the metallic inks made of silver and gold. Now, in order to obtain a small electronic with high quality, we have to pay special attention to the parameters of the ink that are used for the purpose. And in this case, we have 3 important parameters over here, which are viscosity, metal loading, and the particle size. Why is viscosity important in a copper ink? Important because if you want to obtain precise line that are well defined, you need to use an ink with a high viscosity. Also, if you want to avoid double passes during the 3D printing process, you need to use an ink with a high viscosity. In this case, we are recommending a viscosity higher than 460 kilocentipoints. An ink with a copper ink with a viscosity lower than that is not gonna be suitable for our application. Another parameter of the ink that is affecting our final product is the metal loading in the ink. Why? You have to keep in mind that when you are creating small electronics by 3D printing, a sintering process is following the printing process. So if you have a low metal loading, you're gonna end up with less metal in your printing patterns in there. If you don't want that, because it's gonna affect the overall conductivity of the final product. So we are recommending just to create or just to use an ink or a metallic ink that has more than 50% by weight of the metal in the ink. And in this case, I would like to clarify that for the purpose of this research, we are only looking at copper inks made of nanoparticles. Okay, we are not looking at copper-based ink. We are not looking at copper size ink because we want to make sure that we have a high metal loading in the ink. And the last parameter that we were analyzing here for the ink in this research is the particle size. Why particle size? Because remember, we are using a ceramic tip that is going to be micro dispensing the ink in the substrate in there. You don't want that just to be clogged because you want a high, like an end product with a high quality. When you are using an ink with particle size that can clog that tip, then you're going to be disrupting the printing process, and you don't want that because you want a smooth printing process. So we are recommending just to use an ink in which the particle size is 1/10 of the size of the interior diameter of that ceramic tip that has been used for that application. In addition to the parameters of the ink, there are other factors that are affecting the final quality of the printing patterns that you have in there for the small electronics, and that's the sintering technique that has been used. Remember that we are optimizing copper nanoparticles ink, and you know that copper nanoparticles, they are prone to oxidation. Can we use thermal oven sintering technique in this case? The answer is no, because the copper tends to oxidize the nanoparticles. They're going to tend to oxidize, affecting the overall electrical conductivity of the final product. So we're recommending to use laser sinter. Okay, it's not a recommendation, it's a most. In the case of the printer that we have in the lab, we have that feature that can be added. Now, when you are adding the direct laser sintering at the sintering technique, you have to take into consideration the things: the power of the laser, and then you have to take into consideration the scanning speed of the laser too. Why the power of the laser? Too low, and then it's gonna take more time to sinterize the nanoparticles in there, and oxidation is gonna take place. Too high, and then you're gonna be destroying the printing lines in there. So we have to, that's one of the recommendations that I'm doing in the conclusion and in the paper that I was writing, that we have to find the optimal power for that laser in order to obtain, a product with high quality. If we have to combine this laser powered factor with the scanning speed, because if the speed is too low, it doesn't matter. If the speed is too low and the laser power is too high, you can be damaging, the printing pattern. But if the speed is too low and you have a low powered in your laser, then you're gonna observe some oxidations in there. So we have to work together with these two factors to find the optimal power and the optimal scanning speed in there. Okay, this is what we did. We were not able to obtain a copper ink with the desired viscosity. We couldn't find one that is available in the market. We were able to synthesize copper nanoparticles in the lab, but we didn't get the desired viscosity in the lab. Those are recommendations that we're doing over here, also in the conclusion, because we think that we can, we are recommending, we think that this could be interesting to continue with this line of work, because I think that we can find like an affordable copper ink that can be synthesized in our facilities.